right. Can y'all hear me okay? Let me get some music going. Maybe just some like lo-fi stuff. Hey, Rashby Lowe and Robert Yates. How's it going? All right. So, first time doing a Friday stream. Just wanted to get on and do some of that emulation stuff I talked about last stream because I didn't get to it. But first I wanted to check out a blog that somebody on our Discord posted. So ZeroX1C, who's a friend of mine, and apparently it was their first blog. So, and it's pretty awesome from the glances that I took at it. So, it looks like it has to do with this Luma stealer infection chain. And they go through all the different steps of this YouTube video that went over some pirated software that led to this infection chain. And then the URL that leads to the malware hosted on GitHub. And then this launch4j loader that is written in Java, it looks like. I haven't looked at launch4j myself. Yeah, it looks like it's Java. And then it leads to DeFac, or they call it Amber Amethyst Daisy. And then what I thought was interesting was this is JPHP, and I'd never heard of this before. So this is apparently an implementation of PHP on the Java VM, and they shipped this. And apparently Malware for Hedgehogs has a video about it, which is kind of cool. So I guess Karsten goes over DeFac, so that's pretty cool. And yeah, so anyways, pretty cool blog. Just wanted to kind of give a shout out to them on our Discord, and then I'll throw that in the chat there. So, and then eventually it leads to a C++ loader, and then Luma stealer. So a ton of stuff in the blog that I definitely will take a closer look at. But it looks like they go into every single step that's needed to decrypt the C2s, the configuration, and yeah, pretty extensive. So pretty cool. All right. So today I just wanted to get back into this Golang red team tool stuff. I know this has been like a 4-part series now, which is kind of long, but again, like I mentioned, I didn't get to the stuff that I wanted to last stream. So first, this is a payload from a framework called Sliver. And this is written in Golang. As you can see here on the left-hand side, IDA has identified some of the functions that have to do with the Golang runtime, but there's still a bunch of missing functions. It also identified a bunch of libraries and other nicely formatted function names here, but we're actually missing all of these functions up here. So I was just going to run. Hey, Andrew, how's it going? Is it Saturday for you yet? All right, let's, nice. All right, so I'm just going to run GoReSym. So this is a tool from Mandiant that you might have heard of. Let's go to, so these are all kind of tools I want to look at today, but GoReSym is basically a tool from Mandiant that can be used to recover function symbols and a bunch of other pieces of data from Golang binaries. So I'm just going to use that on this Golang binary and then write this to a JSON output file. So it literally has a GoReSym executable that they've written in Golang, and it's going to recover a bunch of data, and then I'm just redirecting that into a JSON file here. So, all right. And then, so once I recover some of these function names, I'm going to show you what I want to do next. And that's some IDA scripting. So we've set up a nice IDA scripting environment here where I'm going to be using a plugin. How do I get this interpreter out of the way here? Or an extension rather, called IDACode. And I can actually use this to write IDAPython in Visual Studio Code and then that will actually send it to IDA, and then it'll execute here. So let me execute this plugin, because I don't believe it's currently running. So if you execute IDACode, so here I can link this in the chat too. Can you paste the link to the Loomis Dealer blog? Yeah, I can do that again. Did I close it? Here, I'll just grab it again. There you go. GoReSym. All right, so no problem. All right, let's do, yeah, so this is the IDACode project that we're gonna be using. And basically this hosts a little server, an IDAPython server, or not IDAPython, but a Python server within IDA itself. And then it will basically listen for a connection from Visual Studio Code to receive code and then execute it. So if we do something like just print hello from, then we can actually run a commandlet here. So Control P, and then, oh wait, sorry. I think it's Shift Control P on Windows. And then I can do connect to IDA and see it says client connected. Oh, something happened, hold on. Socket handler, uncaught exception. Let me try running this again. I just set up this dev environment, so only one user should be socket. All right, let me restart this IDB. In the meantime, let's see how our GoReSym is doing. All right, that's done. So let me show you what this JSON looks like. So as you can see, it's identified a whole bunch of different functions. And we can actually apply this to our IDB. So I'm going to show you how to do that in just a sec here. Let me just open IDA back up. All right. Here, wait, maybe it has to do with the code path. I don't really want to debug this live, but okay. So the next thing we want to do in order to apply all those GoReSym function names and data that was recovered is we want to run the GoReSym IDAPython file. So if I go to script file here and then go to GoReSym rename. Sorry, I'm just going to redo this real quick, guys. I apologize. Red team. All right, let's try that. All right, I think that did it. PowerShell. Why do you encode the redirections as wide strings? Or UTF-16 rather. Okay, so as you can see, even though this is the obfuscated version, so okay, so actually let me back up here. So this project is actually outputting, it has a whole Golang build pipeline, and then it uses this thing called Garble to obfuscate the Golang builds. And basically what I wanted to do, so I mentioned this last stream too, and we looked at this before that, but Sergey did a stream on this thing called Bandit, which was obfuscated using this, and then he used Unicorn to emulate this, these bytes that perform these these string deobfuscation functions in order to recover the strings. So I kind of wanted to replicate his work and see if we could do the same thing. So what I've just done now though is, even though this is obfuscated, basically they just modify function names, but you can still kind of see the original function names in these. So let's see if I can find one of those XOR operations. All right, so I'm just going to set up my IDA stuff here. So there should be strings in a bunch of these, like strings that are deobfuscated at runtime. And we can obviously do some tests ourselves. So I think it's these things. So see how there's these longs that are assigned to these keywords, and then they're stacked at these offsets. And then if we look down here, not entirely sure why this V7 is being assigned, but it might make more sense in the disassembly here. But then, so let's just call this encoded bytes. So because of like a bunch of properties of Golang, we're not going to have the same kind of pseudocode that we would get from, say, a C program or even C++, simply because the calling conventions, if I remember correctly, they are using a peculiar calling convention, and then Golang has a bunch of different runtime structures that it handles itself. So for example, Golang does not have a stack in the same way that a C program would. It has a managed stack, and then obviously the same with the heap, because it has garbage collection, a bunch of different properties that C programs have. So that's kind of why you're seeing these red arguments in the pseudocode and then some other properties. I was just thinking of, Sergey, we can work on this together because you're a lot better at Golang than I am. How can we join forces? Do you remember this, Sergey? This garble thing? Yeah, I just smashed GoReSym and I failed at it because PowerShell encoded the JSON wrong. Very cool. Yeah, basically I'm doing this, but for Sliver. I think you guys have support for Sliver, don't you? On UnpackMe. But yeah, so sort of. All right, so we have, okay. These are the operations I was talking about. So, okay, see how there's these variable assignments and then these for loops with these XOR operations. I'm pretty sure these change like throughout the binary. And basically I wanted to write a IDAPython heuristic to identify these obfuscation routines, so then we can do these XOR operations in emulation in order to recover the strings. So I think there's a new version or obfuscated version or something that doesn't work. Oh, okay, cool. Maybe you can just use this code that I'll write today, but well, you don't use IDA in prod, so yeah. I'm trying to be dark theme friendly for everybody who complains about light mode. All right, so there's a few things we need to do here. So the runtime slice byte to string is going to be what's recovering the final bytes. So we don't want to emulate that function because that's not going to work in our emulation. And then, like I said, we want to identify these types of functions in the first place. Yeah, it's a Go specific tool. It's called Garble. I'll show you the project. We can look at the code too if you want for the obfuscation. So this, it's this thing. Let me link it. I know. I said I started using it recently and so I used it all the time, but I swear I was just using it like an hour ago. Place, create folder. I feel so dumb. I just minimized my whole VM. All right, I'm gonna stop trying to do that. All right, so let's just rename this like MW of example. You can? Where are they? All right, so say we wanted to, so I thought there was more XORs here, so I was going to use that as heuristic, but like there's 3. So maybe we can just write something for that. So I am going to use AI today because I suck at IDAPython. Plus it's the future that's going to take all of our jobs. So I threw this in earlier. I was like, write IDAPython to enumerate all instructions and all functions for threshold of XOR operations and print functions that meet that threshold. So we can kind of replicate this. I don't think, yeah, totally. So let's try this out. Strictly using XORs might not be the best approach. Like we can probably do these, this like a large amount of series of move operations or something, followed by a for loop. But let's just see if I can get that plugin working again. So if I do this code, I can try your script. I just wanted to, basically I wanted to take what you did and then I also have to install Unicorn, but that's not a big deal. You want to do an IDA though, right? Yeah, exactly. So I was basically going to write a wrapper, not a wrapper, but I was going to write something to do basically what you did, but I'll enumerate all functions within the database using IDAPython. And then once I identify those functions, I was going to extract the bytes that I wanted for the instructions that I wanted, and then run this in your emulation, if that makes sense. So let's do the function identification first, and then I'll mess around with the emulation. Yeah, let me see if I can get that VS Code plugin working. I have no idea why this server is not up, or why the server just like breaks. All right, I'm just gonna start a new bolt thrower. What's bolt thrower? Yeah, that's better. Okay, so let's open this folder. All right, and then I just want to make sure that all that autocomplete stuff is still working. So idc dot get bytes. Yeah, cool. So I just put the IDAPython in my Visual Studio path, so then I can get all these nice outputs and stuff. Did I just break this? Come on, YouTube. There you go. Yeah, I would say so. It woke me up though. It's a cool plugin when it works. Quote unquote chill. No, don't say sorry. It's always worth a shot. Oh. Yes, it worked. Okay, so now if I do like print, and then do, oh yeah, see there it worked. So hi from VS Code. Is that really tiny for you? Can I set this font higher? Yeah, I can. Cool. All right. All right. All right, see how it says hi from VS Code, and that was what we had in here. So now let's get our AI script here. Yeah, exactly. All right, so it looks like I have to get used to hitting save just automatically sends it to IDA. Okay, so it looks like, or this might just murder our IDB. I probably should have read the script before executing it. Okay, so analyze XOR operations. Oh, cool. Okay, no, it worked. Save the IDB. Yeah, we haven't really done a whole lot in the IDB yet though. All right, cool. So let's look at some of these subs. Yeah, so, oh man, it looks like some of these strings might be huge, or like normal size strings, but just with a bunch of XORs. And then finding all the relevant ops for the strings might be a pain in the ass. Oh, yeah, that'd be cool. I don't really know if we need to make an IDB snapshot every time though, but I will as we go, like if we get some good results. All right, so our threshold was 5. Are we gonna get a bunch of FPs now if I set it to like 3, because that first function we looked at was 3? And maybe I'll not get it to do the entire database every time, because otherwise we're gonna be here all night. Like maybe I'll pick a target function and then we'll go from there. It's just spinning. Like while that's running, I'll just, it's not too bad though. Like let's use this function, for example. And then we can do something like, oh no, I hit Control S again. I'm gonna keep doing that. And now it's running in IDA again. Whatever. Func EA, get func name. I know this is not an efficient way to do this, but let's just do this for now. Yeah. All right, cool. See, now it's fast. So, okay. So let's work on this function then. So we have a heuristic, but this is actually a good example because there's a bunch of stuff in here before those XORs and then the run slice byte string. So we can probably look for moves, keyword moves leading up to a for loop, or not a for loop, but a jump where our thresholds are met, and then that leads to our runtime slice call, or slice byte by string. Because RSI, let's see. So let's see. So that's the length of the loop. Then we're gonna have run slice byte to string, runtime slice byte to string. I just don't know what the arguments are for this in Golang. So you have temp buffer, and then it yields a string. So we have the first element of the slice. Hey, thanks for the follow. I'm too lazy 0 and believe. So yeah, the first we have temp buff byte, and then the this I assume the number bytes. Yeah, length of the slice, pointer to the first one, and then the result. So we're gonna want the first argument, or no, sorry, we don't actually want to call this. So we're just gonna want the number of bytes and then the pointer to the first byte in the slice. So yeah, I do want to do the microcode stuff. How long do you think that would take compared to using this? Yeah. Let's see what if the AI can do it. Is it IDAPython even? Do you want to just see if this works? If you want to try build off that. Actually, Brett. Oh, cool. Yeah, like this looks okay as long as it's not complete BS. Maybe let's start a new script that tries some of the microcode stuff. So source operand. So can you not access the actual hex arrays bytes? Can you only use the microcode? Okay, so I shouldn't specify microcode in this request then, right? Just Brett's blog. Here, I'll just look at it. Come on, Zscaler, get dark theme. Light theme Chad. Oh yeah, this is even similar obfuscation, except way harder. All right, let's look at their GitHub. It's CPP. Oh yeah, sorry. I thought you were talking about the plugin. That was the plugin C++. I don't know if I want to venture down that road. I just haven't used like, because I would have to set up Visual Studio, I think. Anyways, let's read this. So there's a callback. Okay, this is all UI stuff. We have a visitor. Don't do that. Easiest way is to go to Binja. Nah, I've been like strictly doing Binja stuff. Peekabot, scary. Yeah, fortunately we're not having to deal with that. Here, I'm just gonna download this source code because I hate reading source code on GitHub. Let's just client here. All right, let's look at the base class here. It's cool because they have like a heuristic.cpp and all this stuff. Let's install the C++ extension. If it wasn't for the inevitability of me struggling with the build settings in Visual Studio, then I'd be up for this, but I just know that's exactly what's going to happen. Yes, switch to it. But yeah, let's look at what they're doing, because I think I can call similar functions from IDAPython, because it's basically a C++ wrapper. Why is this taking forever? I shouldn't have done this. Yeah, peace send packet. I gave you a shout out at the beginning of the stream, by the way. I forgot to tell you for your blog. I didn't actually read it all yet, but I just said it looks really good. But I will be. Okay, so plugin.hpp. Oh, cool. All right, where's the heuristic? I want to look at the heuristic. Is AES function. Oh, yeah, it's using these microcode operations like that we saw earlier. How does this, if it's an STX, I don't even know what these microcode operations mean. Mop n. Yeah. Do you know the what's the IDA plugin for getting all the microcode? Because I actually kind of just want to take a peek at this real quick. You had it in your video, Sergey. Lucid? I think that's it. Yeah, this is it. So like, because if I could actually visualize the opcodes, it might not be so horrible. did you say throw this in the, yeah, into the plugins. Restart IDA for the millionth time. Okay, let's see if that, I assume it's under here. How do I open Lucid? Oh, cool. You just right click and do view microcode. Wait, what was that? What plugin is this from? What plugin do I have installed that gives me the option to do obfuscate arithmetic operations? Oh, what? So can we use that? Goomba. What's Goomba? Man, I really need to take advantage of these things. Hex arrays. Like, these aren't MBAs, so I don't really know what this is going to do for us. Here, I guess it's not going to do anything, right? But it's still cool. Like, I guess it probably can't do for loops, right? Yeah, okay. All right, but see, now we have this cool microcode. So I don't know. Well, maybe cool is a strong word because of its readability, but so I think the LMAT LVARs is the first layer. I can't remember. LMAT generated. I think this is probably what they're accessing. But like, how is this? Like, can you just access this STX? Is that the advantage here? Like, STX is probably like stored extended. Very intuitive. Yeah, like what does their plugin do? So STX found, right? So like they're looking for the STX operation, MSTX. And then somehow for all instructions has side effects. This API is not it's like they're doing, like, it has to be more simplified than the, so MAT generated. Okay, yeah. So local variables. Like, I feel like I'm missing something here because shouldn't this be more optimized? Anyways, why don't we just use IDAPython? And if it's horrible, then we can use something else. But I feel like this obfuscation is basic enough that we could use it. Generate is the first level. There's no optimization. Oh, okay. Yeah. Okay, that makes more sense because it's, so LVARs is the final one. Oh yeah, okay. Yeah, it looks a lot more optimized. So we have generated, which is like all of these instructions, and then they kind of get folded early on, these integer assignments. And then this call runtime slice. Yeah, it's kind of hurting my eyes / brain. Like, I know these microcode layers aren't really meant to be accessed by normies. Light mode required, yeah. Because, like, it's not really like it's these integer operations and then the for loop. Like, there's all these calls in between. But if you look at the actual disassembly, then it is actually the, oh, maybe not, D7F8 90A, yeah. So it's like quite a bit later on. So this will give you the data buffer. Yeah. But it won't give me the actual values, will it? Because I think these functions differentiate, or sorry, these like for loops differentiate. Like, they're not these subtractions every time. Like, sometimes they're XORs. Like, it's probably useful if we still emulate it. So like, if we run our script again, oh yeah, I probably lost connection and it's not connected, right? Let's try this. So basically, I just want to see, like, his hex arrays isn't able to actually do those arithmetic operations that precede the integer variable initializations or whatever. So let's take a look at a few other examples. So like, I don't know if this is probably a false positive. Like, here's another example where there's, you know what I mean? Like, the ops differ substantially, so we'll probably want to emulate it. There's just a microcode exception. Maybe I'll close this Explorer for right now. What's the hash? This is I generated the sample with Here, I can upload it to Unpack Me though. I already logged in to Unpack Me because I thought we might need it. So I'm just doing this off screen because I don't want to leak stuff. I got a LinkedIn recruiter job offer for working at HRDevHelper. Maybe I should accept it and just work there for a few months to rewrite some APIs. It's not a bad idea. Oh, so Malpedia, the Malpedia rule hit for Sliver. Let's see what insights we get. Oh, sorry. Yeah. Let's put the hash in the chat. It should be available to everybody on Unpack Me, right? Because it's a public run. Cool. All right, not packed. Cool. Oh yeah, no config though. All right, so I was gonna copy out these XOR results so I don't have to keep running our script to get more examples. So let me do that real quick. Maybe it's huge, so maybe I don't want to copy all of them, but yeah, it's probably good enough. We're in the A's. Oh my god, this binary's huge. All right, let's just copy this into a new text file. No, just a new text file. All right. So yeah, like I hope these runtime grow slices aren't what we need for the C2, because that'd be a giant pain. Like when we looked at the plain text example, there was the Golang interface that provided the C2. But when I diffed them that first stream, I wasn't able to get any solid diff indication as to which function was the C2 interface that we could use. Call analysis failed. But like remote address, that's probably the, like, is this it? Here, let me turn off the syncing so I can actually go there. The one thing about dark mode is like these borders are hard to see. Many things about dark mode. Grow slice my cake. Anyways, I won't dwell on these too much, but I suspect there's going to be a bunch of these functions that we can't identify super easily, but I think we'll do our best here. HP util. Hey Ahmed, thank you for the follow. Not on Twitch, thanks for the follow. Karan Stark, thanks for the follow. Reverse proxy, copy response. Anyways, we can look at the plain text version as well. But why don't we keep, here, I just kind of wanted to look at that heuristic a little bit more. But again, there's probably things in this that are over my head. So the RC4 visitor has side effects. So I assume has side effects means that there are, like, the hex arrays operations result in some change of state within the program, maybe. But these are all just guesses. I should probably see if there's actually a good explanation for these. Yeah, this API seems pretty crazy. Yeah, it's the Copilot chat. Keyword visitor assignment. No, it's I think it's $10 a month US. It's not terrible. But I feel like we're at the stage where all the AI tools are really cheap to get everybody using them, and then they're just gonna like jack up the prices. It's weird that they import it this way. Yeah. Total keyword assignments, keyword assignment visitor. Yeah, so these visitor classes are like callbacks. And then there's a CTree visitor. Yeah, this API. Code assignment is in 64. Ugh, gross. Let's see if this works though. Okay, so it initializes the hex arrays decompiler for function and each function. So let's just do our target function again. So let me copy this into our Windows box here. All right, so we'll do another new file. Let's call it like ungarble hex arrays. All right, send it to IDA. So we'll see what happens. Did we get anything? IDA funcs. Did it execute it or no? Oh, because we're not calling the main function, that's why. Oops, sorry, I'm used to writing C. Nothing is happening. I'm a total beginner in RE. Is it good to start with C or C++? I would start with C just to get a feel for how low-level programming works, and then try writing some C++ because there's a lot of helper functions and a standard library and things that'll help you with all the things that you have to do in C yourself. Hopefully that helps. It would help if I could do this properly. IDAPython's not defined. Oh no, hallucinations. I wonder if this takes hexarrays decompile. Let's see what hexarrays decompile takes. Just an address. Okay, so we don't even need this thing. So let's do funky A. And then, but maybe let's not do this and just do it for a single function here, because otherwise it's going to decompile every function in the database every time this runs. I'll do funky A, one of those target functions that we had earlier. All right, let's try this. Nice, that worked. I think if there's 5 keyword assignments in here, 3, 4. There's another assignment somewhere. 1, 2, 3, 4. There's probably another one somewhere that I can't see. Followed by a call to, I just kind of want to see what this shows us. Maybe the CTree level that's being parsed isn't fully optimized also. Yeah, I think you're right. I think as long as it was close, then cool, nice. All right, visit expression. It's just like caught assignment. Like this stuff is gonna be, let's just put this in. But what's nice about having the autocomplete is that we can check what these different patterns are, hopefully. So like caught assignment, but like what does ASG mean? X equals Y? Is that a part of the docs? Is this pulling the doc headers of the constants? Variable. So let's just do caught add. Oh, cool. Caught add assign is going to be a plus equals, yeah. All right. Well, although I don't really know what I'm doing, these parts of the API seem pretty straightforward. So there's like an expression and there's an operation. And then if it's equal to an assignment and the expression X, let's see, expression X. This is not a friendly API. Some after stream reading. Oh, cool. Nice. Yeah, thanks, Robert Yates. Yeah, I don't want to read a blog on stream. That would be super boring. I feel like we can get this working on stream too. But yeah, I feel like using the hexarrays API is the way to go here, because we're always going to get a whole bunch of, like, it's, I don't know, the IDAPython API is not great because you're always walking to the next header and then you're looking for another integer assignment and then you're looking for, like, it's just not great. So, but this is pretty cool actually. Can you guys see that okay? Is that better? Is that like massive? Are any of you on mobile? Yeah, let's put this in our notes actually. You're watching on the iWatch. Nice. Copilot doesn't suck at writing IDAPython with the hexarrays API. Here, I was gonna link the Lucid plugin. I can do the rest of these off stream, but yeah, I'll do the rest of them off stream. Oh, and I'll put the Zscaler blog in there with one eye closed. Yeah. All right, let's see. Let's run this thing and see if it works. So, okay, so next expression. Okay, so I think we're gonna have to loop because it's gonna be a for loop followed by a bunch of stuff. like it's going to be this for loop and then the for loop body. So we're going to have to find the end of the for loop body followed by a runtime slice byte to string. Panic check. Ugh. Maybe we can avoid these calls and our emulation somehow. What you have notes, is there a blog somewhere? I threw these all up on our GitHub. I can link the GitHub. Usually, so like once I finish a stream series, then I'll usually do like a full blog. So like last time we did invoke. It would help if I could type my own website. So last time I did this one on the CACbot malware analysis scripting stuff. So actually, while I have this, so shout out to Recon, who is hosting a really good reverse engineering conference in Montreal next week. I will be there, and I will be doing a workshop on this, basically unpacking CACbot. So I have a full workshop write up. It's like 21 pages, and I'll be doing that live in person in Montreal on Sunday afternoon. So if you be at Recon, come say hi. Yeah, looking forward to seeing you. IRL. All right, so let's see. I think we can close this for now. That was just the plugin from the blog. Okay, so let's run this. So I'll hit, oh right, so we needed to fix these expressions. So I think I can just do a for loop of, so it's gonna be the visitor class. So I don't know if we wanna have because basically this is the visitor that's gonna be executed within the callback, I suspect, while it walks the tree. So I think this expression is gonna be executed on each operation within the tree, I think. And then this is just like forcefully getting the next operation to look for a call. So I guess we want to put our business logic like in here to know if we're going to hit the for loop. I'm just trying to think about how this works. Oh yeah, we need to fix this again. So we'll do funky A is going to be our function here. Okay, and then we want to get rid of this for loop again. And then we can get rid of these continues since we're not looping anymore. And then this isn't going to actually yield an increase in our pattern counter. Self.pattern count. Right, so it's doing a super, so I'm just trying to figure out how this works. Okay, cool. Yeah, it's just accessing the class variable from the visitor. That's cool. So yeah, we can put all of our business logic in here. So let's just do, is that the right term? All right, so we'll walk all of our expressions in here. And this would basically be the same thing that we'd do in regular IDAPython with the operations, but this actually might be super useful, because if we can identify a sequence of integer assignments, we can actually capture all the bytes within that for loop. We can find which of those for loops are like calls that we don't want to, or that we want to ignore, operations that we want to ignore, and then we can just emulate them. So this is actually really awesome. As long as I can figure out how to get the bytes out of the function, but hopefully the AI can help us. Like the bytes, the function bytes out of these expressions. Yeah. All right. So yeah, I'm actually pretty excited about this. All right. So let's do the next expression. I don't think this, well, we can use this as like an iterator. Wow. I just don't know what this is going to yield in return if there's no instruction. Whatever, let's just try it. while, I don't want to loop forever. So let's just do while expression, and then we'll use, and then we'll do while has expression. We'll get the next expression, and then I'm just gonna set a max on this because I don't know if we're gonna be able to get out of this. There's been a recursive design issue to take into consideration, I guess. The visit expression is per expression, but you need to capture a kind of ongoing state. That makes sense. Yeah, so I'm kind of breaking the recursion here because it's essentially going to recurse over the tree until it hits the, like, this state, right? So if expression is an assignment, and if it's a integer assignment. So basically I was just going to iteratively go through, I'm just trying to think. Like once we got to a integer assignment within the recursion, I was going to do the rest iteratively, if that makes sense. Just to avoid my confusion of the recursion that's happening. But I think we could do some top level like globals if we want to do that. That's kind of what I did with, actually, yeah, we could do this in a global, or not even in a global, but in this top level function here. That might be cleaner. Because then the visitor is handling all this stuff that I was just going to do. Yeah. But I think like what you're saying might be cleaner. So we actually want to get this call stuff out for now. And then I'm just going to increase this pattern. I'm just going to make sure this is all working. IDAHexRaise has no attribute next expression on line 15. All right, that might be a hallucination. But we won't really need that anyways. So, all right, total occurrence is 5. So that's what we got before, which is good. And then we can say visitor applied to C function body. Yeah, this should be able to access this variable, right? If not, I can make it a global, but found, what we're gonna need too, we're gonna need the integers, and then we're gonna need the total bytes at some point. That's kind of for later. And then we're gonna need the is found string slice. That's kind of found str op. All right, I want to see if I can access these from these calls. I suspect it won't be able to, but yeah, even Visual Studio saying it's out of scope. Okay, so we'll have to make it a global. So let's do these up here. Ugh. Oh no, I don't need these up here, sorry. Don't I need the global keyword? Cool. No, I do not. And then let's put this stuff in a separate if statement. If it's a call, and then we have the called function. This is our expression. And then found operation is equal to true. And then we're going to want, let's just try this first. And then something like that. All right, cool. So I don't know what these swig objects are, but that's okay. I don't know why we're getting 2 trues here, but stuff happens. So I wanted to see if I can print, like, a pretty print this expression to actually, so it's not just like this swig object. Oops. Format. Let's try that. Might be a hallucination. Drink it live. Format. All right. So, okay. We could probably leave this for now. Expression dot like I don't know what any of this stuff does, like CV fast. Do not maintain parent information. I guess it doesn't really matter. Okay, expression. Okay. Tech Tuner, thanks for the follow. I forgot to give you a shout out earlier. Okay, so, all right, so now we've identified a single expression. So what we really need to do is identify the point at which we get like 3 of these in a row. So that's the part that might be a pain, is knowing at which point we've seen that 3 times in a row, but we could probably do it with this global state thing. With like an else. And then we'll just have another case that's if, maybe we don't want to do this recursively. I guess we can, because I could do like if the count's high enough, and then let's do it. IDA hexarrays caught. What do you think a for loop is? 4. Call, cast, comma. Yeah, always a pain. Maybe its caught instruction is equal to, like, this is why the binge API is so nice, is because I can just like get these objects in the REPL sub. But maybe it's not an operation, right? Maybe it's something else. Let me just use AI. Cost assignment indicates that the node is an assignment expression, while the CIT if. Oh, cool. Okay, so there should be something similar. Let's see if AI knows. CIT 4. C for T. Yeah. Op. Print found for loop. So the thing here too is I want to be able to know that we're in the correct for loop in our test function here, but we'll see. Like I need to be able to, maybe I'll ask AI again for getting the address of the current expression that we're visiting, and hopefully that's available after a number of, so that logic is sound, right? Like if we're seeing integer assignments and we increment the global count. Oh, maybe we can do this at the class level. Yeah, let's do that. Globals suck, if I could spell. So then we'll do self count. We don't have obfuscated ints or total bytes yet. Oh yeah, thanks. And then we should see if there's any incorrect. Yeah, it's cleaner. Oh wait, no, we're gonna want total pattern count. Oh, we don't need this. Visit, what do we call it? Pattern count. Visitor.pattern count. See, why do I have to change stuff when everything was just working? It's probably being reset to 0, but we're not hitting this state right now. I'm just gonna print out the count every time. Or just do, okay, cool, yeah. So found integer assignment. Is this a keyword though? This 7 thing? We might want to not only use keywords. All right, we'll just do integer assignments up to a for loop. Oh, it's gonna be a pain because we're gonna have to cover every size of integer assignment. Let's get AI to do it for us. I just realized my camera's off. I'm going to fix that during the next bathroom break. Let's just finish this first, then I'll take one. Maybe a better approach is to find the for loop, then grab the variables. Oh yeah, that's a really good idea actually. Yeah, we can do that. I wonder how I get to the end of the for loop. I want to see how this did this. is integral. Nice. Let me just try this integral thing and then we can look at the variable assignments. Sorry, I'm just trying to see if my camera will come back on, but let's see if this integral thing works now. And then type object. X subtype is integral. Yeah, we want this to be, oh no, that looks right. But we need this to be the old way of a conditional assignment, not conditional, a COD assignment, and then like this. We didn't hit our for loop condition though. All right, I'm gonna just run to the washroom and then I'll fix my camera and then hopefully everything comes back up. So I'll be right back. Let's keep going. All right, take care, send packet. Talk to you later. Yeah, I don't think we can access these at the class level. That's okay. Here, let me get rid of this. Okay. No, yeah, we can. I just don't know why. Like maybe these aren't in the tree, like how we're seeing them visually. But I liked Robert Yeats's idea of looking at the integer variable assignments and then accessing them that way. Let me think. So, okay, so let's just store all these operations, but I just want to be able to make sure that I'm getting the right variable assignments. And how can we do that? Because they're different sizes. This is harder than I thought it was gonna be. But we can do it. We can do print found other operation. Although maybe a variable will only point to one value. Yeah, I agree. I think the variable assignment might be overcomplicating it, but let's see. Yeah, the type might not be always there. So let's try the operation. Here, hold on, I'm just gonna fix my camera because it's in the way of my screen now. There we go. That's better. So are these, I don't know what these constants map to. So we should, this is a really ghetto way of doing this, but we should see 65.1, 65.1. Yeah, so we're seeing the 3 variable assignments. I just don't know what these numbers map to, like what 65 is and hexer is, the type of operation. Maybe there's a enum of these somewhere. Have a CTree view. That's a good question actually. Oh great, hexer crashed. So let's try doing that one more time. But if hexer crashes again, I probably won't open the microcode menu again. There we go. Yeah, I don't think so. Yeah, that would make things like a million times easier. There's got to be a better way to do this. Maybe the first step is store an expression dumper inside the visitor. Yeah, I just want the expression representation. See, like I want these C types. Like where are these all defined? Yeah, that's what I'm looking for. What are the ops that we were looking at already? COD call, for example. Expression op, COD assignment. Let's try that. All right, here we go. All right, manual expression dumper it is. This is so gross. But this has to be like a dictionary in Python, right? Piece of the Copilot. Yeah, that's a good idea. I think we can do this. Hell yeah, good idea, Robert Yates. No, do the whole thing, not just up to 18. How does it know the? Oh no, that's because they're there. One vulnerability. Do you see that? Oh my god, no! Just give it. Why would it do it for me? Just skip from 18 to 49. And only went up to 69. Alright, maybe we'll just do this by hand. Or I'll just say, here, let me clear the chat. This is the worst. Alright, I get it. Let me just see actually if these are in IDAPython. They should be. But I don't know if this is just like the C++ interface. So just one giant Python file. Yeah, it doesn't have the integer mappings. It just has the C header mappings, it looks like. Gross. Oh. All right, let's hurry up and do this so I don't have to, or I have a better idea. Let's just generate, I might give up on AI doing this pretty quick here. Yeah. Do we want to do this in here? Probably. I just sent that to IDAPython, so it's just gonna run it in IDA. Did that not copy the? Whatever. Feels bruh, thanks for the follow. Menji, thanks for the follow. Hope you all are having a good night, or whatever time of day it is where you're at. All right, so let's parse these. So I'm actually just gonna run this from IDA because, I don't know. I think we have idle on here. Did the regex not even work? Do you see this, Robert Yates? It's looking for a digit colon string, and that's not how this is formatted. It's definitely not taking our jobs anytime soon. Okay. All right, I'm gonna do this on regex.org because otherwise I'm not gonna be able to do this. Or regex 101. Actually, let's just do. Writing regexes on stream. Who would have thought? All right. Okay, and then let's make a dictionary. I guess I could have done this all in Visual Studio Code. I'm not really used to using it like that way. That's okay. Whatever gets her done. Then we'll do, let's do single quotes. All right, we finally have a dictionary. I forgot to do the commas. Thanks for our case. But shouldn't ChatGPT be doing, or sorry, shouldn't Copilot be using ChatGPT 4.0? Maybe I should just pay for 4.0. Regex is hard. There you go. Probably it's token limit. Yeah, I think you're right. The response token limit. Yeah, it's probably just doing code snippets for the most part. I think that's a very good guess. Okay. Oh, crap, we want it printed out the other way, don't we? I'm just gonna use yours. Thanks for doing that. Okay. All right. Let's figure out what these expressions are. ctype_t, yeah. Oh, is this server not even up? All right, cool. This is nice. All right, so we have our call. What? There's no call here. Let's just double check the address is right. C640E0. Call object. Okay, so maybe the call is just the beginning of the function, I assume. Because there's a cast, reference, variable pointer, cast add, variable number. Yeah, okay, that looks good. Integer assignment. Okay, that looks good. A variable with a number. Excuse me, sorry. Oh, it's because I'm doing this wrong. So it's gonna walk each of these parts of the expression. So yeah, I feel like doing this recursively is difficult, but I think we can just get around this by having a caught variable in our if statement, or whichever's resetting that counter. Recursion is hard because we have the caught assignment. Yeah, it's all good. Caught assignment. We want a caught var, caught num. Sorry guys, this is really boring, I think, for some of you, if you don't know what's happening. Cotnum. Basically, we're just walking these instructions, and then I'm just trying to get a global recursive state to the point at which we're being able to get the correct count of integer assignments that are followed by a for loop. So was this a string copy before? I can't remember. Let's check out some other example ops. Collective R&D stream. Yeah, I think it's great too. See, like this string assignment might screw us over. String copy rather. Let me look at some other examples. I guess it doesn't really matter if there's just accommodating for all of these corner cases might be a pain. And these aren't even the functions we want. All right, here's another example. That might be better to use. We would call, okay, so like these sequences seem to be constant. So a call followed by this keyword call thing within this if statement followed by these ops. So that's also good. And then these are just those panic hatches or whatever you want to call it. Panic handlers for these integers. I don't know if we'll have to worry about those, but okay. So yeah, this is a good example. So we basically want to just double make sure that we're going to hit the correct case here. So, oh no. Now we have pointer casts to worry about. I might just, yeah, this is a pain. We could just keep adding stuff to that check before we set the count back to 0. It's kind of gross though. There, let's make these side by side so it's a little bit easier. Let's see if we can get some of this real estate back. All right, so we want, let's make a list of operations that are within scope of this function. So let's say in between ops, and we'll say, basically I'm just gonna make a list of operations that we can ignore in between. So we'll have the 2 that are in there already. I was trying to format this better, but whatever. There we go. And then we had cast and pointer. And then we're gonna want to check if there's like that. Can I not do that? Then we want to set this to 0 now. We're probably going to find other corner cases, but all right, hopefully this hits. Let me get rid of some of these. Yeah, this is weird. This global state's weird because we're not at 2 when we're hitting that for loop. Oh, are we just not hitting that for loop expression at all? That's not good. Greater than equals. Sorry, I'm just trying to see. Wow, what? Why isn't there the for loop in this? Again, I'll double check that we're in the right function here. D6, DC0. And like, I'm just printing out every expression. I'm not doing any other business here right now. Maybe I do need to take a look at that hexrays blog. Or not hexrays, but where's our notes here? See, like, how did they get these expression graphs? Example below the condition. Yes. HRDevHelper. I definitely should have looked at this blog before. All right, let's get this, and hopefully it works still. It looks like it was updated a year ago, so I'm too used to PowerShell. That just like does things for me. So there you go. All right, I'll restart IDA. Here, let's see it. Plugin usage and shortcuts. Right click in the decompiler view. Show CTree. I don't see it. Oh, was there? HRDH. Do I have to copy the entire thing? Probably. All right. Yeah, I was missing something. Control dot. Look at that. And it highlights it too. Yeah, we definitely should have looked at that blog before. All right, I'm just going to close the disassembly. All right, let's see the... Okay, so these expressions are made up of... Oh, this is crazy. Cool, okay. This is way easier to read now. Instead of just like printing in the dark, basically. This is really cool. Wow. Because is this expression made up of a block? Or is this just... So there is a for. So I wonder if we can like access these subblocks. And then we can avoid doing all this crazy recursive stuff that we were doing. Nice. For expression. Yeah. Yeah, I suspect that's the case. But would that be in our expression thing or no? So we can do something like I don't know how to know we're in a block. Let's see if the AI knows. Yeah, I think you're right. Overrides. Okay, yeah, let's see if I can figure out how to walk these blocks rather than each expression. Okay. This is an INSN, which would be instruction. Block.serial. But is that that's a address, right? D2. Yeah. So now it's telling me to use the microcode. But I don't know if like the microcode, let's just try some of this. Like this seems very different than what I was doing before. Cause like here we're doing a recursive walk using the apply to, but it's all very confusing. Okay, maybe this is expression op name might be what we want. Let's just print out all the op names. Oh, oops, we don't want that. We don't want it accessing our dictionary. Okay, so this is kind of what we wanted earlier with our dictionary. So it was op name. But I still don't see the if statement. Like I don't know if this is accessible via this API. Or like you said, we need to be walking something else rather than the expression. Yeah. I don't think that's right. I think it's lying to us. Man, I was so excited about this, but now it's we're hitting roadblocks. Okay, so we can hit, like, I just don't know if these are all if these are all hallucinations, right? Like this looks great, but we definitely can't find the CIT for, so because I was printing out all the ops before. Let me just try. Oh, really? Visit. Oh, okay. So the AI is telling us different stuff. CTree visitor T, visit INSN. Yeah, okay. So do you think there's like we're overloading this particular class name, or sorry, class function in order to get access to different things? Yeah. Okay. So yeah, I know you said that a while ago, but so let's copy this into a separate function, or sorry, a separate file. And then we'll just call this walk for, and then we'll yeah, exactly. No, I'm pretty sure, right? So this died on for loop.iter. I don't really care about this stuff yet. We're gonna care about it in a sec, but what I bet, I don't know. Hold on, let me just run this. Print C item. See, I think these are all hallucinations. Found a for loop. Now what are all the available CITs? So I'm just going to print all the op names now. I assume it has the same things. Do we have the op names in this view here? So this is a 4. Like, I wonder if we're going to see blocks now. Yeah. Hopefully. And then these variable assignments are going to be just expressions, I guess. So I suspect we're going to be walking instructions for block expression. Yeah. And then I suspect we're going to have to walk the, like, I wonder if we can walk the expressions within a given instruction. Man, Robert Yates and I have just been like struggling through this. So sort of, not really. But yeah, Robert Yates has been a huge help. We were, you should have seen us earlier. We were making regular expressions to parse the C header files from the Hexrays API, and it was great. Okay. So if we have the for loop, oh yeah, I was just going to print out all the operations or all the instructions, and then we'll do insn.op name has no because this is just going to give us integers now, aren't they? Oh, it wasn't op underscore name, it was just op name for the other API. Okay, there we go. Yeah, okay. So we were right that this, oh yeah, so Sergey, there's this cool plugin called, and I'm going to put this in the notes too, HRDevHelper. And like HR's Hexrays DevHelper. And then it gives you this cool graph of these higher level instructions, Hexrays instructions. And then it'll highlight them based on what you select in the decompilation view. So a few things happened. First, the AI gave us the class override to walk expressions rather than instructions. So we were trying to find a for loop given expressions rather than instructions, which we're now walking. So this is what we want. We didn't really want well, I think we do want the expressions eventually, but yeah, it's definitely not straightforward. How was your walk to the shop? Cheers. This mess. All right, so I think we can, so this for loop then leads to expressions and then a subblock. But I kind of want to just like, I want all of this. I want to capture all of this for loop. Yeah, the Balmer peak. I haven't read XKCD in a while. Is that still a thing? All right, so within the for loop, we have these number of expressions and if statements. I guess I'm kind of getting ahead of myself because we want to parse each block. Okay, I guess we can just grab the block before the for loop, and then that'll have the integers, right? That'd be really nice if that was actually the case. So like, what block has these integers? Can I view these differently though? Like, can I do, I can't remember what it said for the shortcuts. Show tree, conflicting shortcut, focus CLI to, sorry, one sec. Okay, so there's CTrees and then there's subtrees. Oh my god, this is crazy. All right, so how do I do a subtree? Control Shift dot. Cursor must be placed on a C item. So this is a num and an int. Like, I want this. Give me that. So what's kind of cool about this is it knows that this is a byte array of 11, of size 11 on the stack. Am I interpreting that correctly? Would it actually be 11 though? It'd be a hell of a lot more than 11 if it's accessing the third keyword index. Because that would be, yeah. I don't know what this means. All right. Okay, so we know that we're going to have to access a subtree probably at some point to get the actual values out of this thing. But let's get the for loop. So like these numbers are available within the high level tree. So I actually don't know if we'll need it. But so we'll have a block and then a for loop. All right, so let's try coding some of this. So I don't know if I can actually get the for loop body, but let's try that. And then get rid of this. What's the body? It's a CINS. It's an instruction. Oh, cool. Yeah, thank you. That was just like based off what the AI said. So, but I don't know what I can do with those types. I guess we don't need what's in the body, right? But let's see what. Okay, so the block. Okay, so let's just access the first block and then see what we can get from there. Because I'm assuming this for loop is within a block, yeah. Change the expression. Oh, cool, okay. Like this? Or what do you mean? Change the expression. The print line above. Yeah, like this won't print out a string. I did that before. It just gives me the swig or the CINST object. But I guess I can look for this in the hex arrays. Oh, print C item. Why do you need the tag remove? Where did you find this? Robert Yates. AI found it in a hole. All right, let's try this. Print C item. Cool. Print function. cfunct print DCL. Man, this is crazy. Like, I don't even know how they can keep track of this stuff internally. So like the INS. But yeah, I'd really like convenience functions like that. We need Rolf to come help me. But then he'd be like, why are you using IDAPython? A C statement can be compounded with any statement. Okay, so it looks like their header file is actually pretty well documented. So keeps general information about the decompiled code, including the MBAT. Deleting the cfunc will delete the MBA2. A C statement can be a compound statement. Okay, so we're looking at the compound statements like if, for, while, return. And then we have expressions, which is what we were looking at. Items, and then numbers. So we basically want to parse the I'm not entirely sure what MBAT is, but basically we want the instructions till we get to the integers, and then we want the this is horrible. Like, are these integers a part of an expression? Yeah, they are. Okay, so okay. So we basically just want like 1, 2, 3, 4, 5 expressions followed by a for loop. 1, 2, 3, 4. I don't know why there's 5, but okay, let's start with that. Let's get back on track here. So we can say total, and then dot op is equal to IDA hex arrays. Wait, sorry, I'm getting sidetracked. / tired. Expression. Why am I doing this through globals? We already established that you can do this through the class. Self dot total expressions equals 0, and then all right. What's wrong with this? CIT. Are you crazy? Why is this complaining? Thank you. It's getting late. Right. Okay, so now we're in good shape. Now we're kind of where I wanted to be with those. Oh my god, I keep forgetting the terminology. Yeah, expressions. So this is basically what I was trying to do earlier. So if it's greater or equal to 3, this is kind of arbitrary right now. We probably want to change this later. Invoke period. Yeah. All right. So, all right, this is gonna be horrible. Are you ready? I don't know. We don't even want to do that. How are we gonna capture the bytes in these expressions though? Slash instructions. There's got to be like a starting address, right? We don't even need to capture these. We don't even need to capture these integers because we're gonna emulate this. So we'll do start adder. Yeah, unless you think, like, because I think these operations vary. No, do you think these are like the same ops? Yeah, I'm like overcomplicating it probably. See, because like this is doing just a negation. You know what I mean? So like we're gonna have a bunch of scenarios where these interoperation or these subops differ. So it's bureau pen. Is that I've never heard that expression. It's probably like regional. I don't know where Robert's at. You mean this thing? Yeah. Okay, so all right, so you're saying parse these integers and then parse the inner expressions in the for loop and then like perform them. And it's definitely later. Isn't it like the next day? Like, are people waking up in Europe? It's a modern kind of... Wow. Well, thanks for staying on. Feel free to drop off whenever. But Sergey, you think it's a worse idea to emulate? I feel like I'm going to spend all night just capturing all this. Crap, where did it just go? Here. Yeah, so the expression part I'm not sure about, but you can defs get the expression in the loop, the buffer, and the length from the microcode. I just implement it dynamically. Yeah, it definitely looks kind of effed if I would try and emulate this entire function, so I think that's probably a better idea. So, yeah, exactly. So let me, basically, just because of my unfamiliarity with the Hexrays API, it just took like a long time. The buffer and the size. Right, because the buffer is in the for loop definition. Or sorry, the number of iterations is in the for loop definition. But like oh no, yeah, you're right. So the slice length is hard coded. And the other thing I can do to identify these, which is probably a way smarter way to do this, is look for calls to this slice byte to string. Oh my god, why are none of these decompiling? That might be another problem if our target function fails to decompile. Yes, so this is where I'm not sure, but I think you can also figure out the expression. But Hexrays isn't going to do that, right? It's not going to perform that expression. You know what I mean? Like this one's really easy, but it will give you the actual expression. Right. Yeah, for sure. Which is way better than the disassembly. Okay, so maybe just so I'm not up till 3 a.m., I'll do like this one as an example. And then I can probably find more complex ones. But what I was saying earlier is like, I bet an easy way to find, yeah. No, I think it's probably cleaner to try evaluate the expression, because I bet there's only like a subset of these, like of the patterns he uses. So like we saw the negation pattern. I don't know why none of these are decompiling. I don't think I've ever seen this. I might just restart this. Oh god. Here, 1 sec, sorry. I just don't want the garble guy to watch the stream and then add more cases. Once you have the loop, you can grab the variables. Yeah, totally. And yeah, Robert Yates, that's all right, so let's focus on capturing the body of. So what's crazy is like this is 10 billion times easier in Binja. But the decompiler is nice, so. And it's also, I should also say it's because I've like my lack of familiarity with the Hexraise API. I'm sure there's like people on Brett's team are obviously wizards because they can write that Picobot plugin. All right, so I'm guessing the body is made up of expressions. See, now the HRDevHelper thing is showing up. Show context. Is op. IOP is IDAPI cod call. Cool. So now if I do like this, show context, cod var. So we probably want all of the operations for, how do I walk the operations in a instruction? Let's see if what made you say that? Or what made Shan say that? Oh, still like. Yeah, it's really weird that she asked that question because I just had mac and cheese like 2 days ago and I was on a call with work and the ketchup bottle was like sitting in my webcam view and because I was eating mac and cheese like 2 days ago. Sometimes it depends. It's usually if the mac and cheese is terrible, then I'll usually put ketchup on it. That's funny that she remembers that though. I don't even know when we ate mac and cheese together. Oh, awesome. Yeah, that sounds great. Okay, so let's get back to the for loop. All right, so I think I can access the expressions within this for loop. Why is this graph like this? All the nodes are like clustered together, so that's why they're all like. How do I make this like refresh? I think I can actually refresh it. Oh no, I can't. Layout graph. A custom layout for the current. Yes, I want to delete it. It looks horrible. There you go. All right, so the for loop, and then the for loop body. Yeah, let's just see. I feel like emulating would just be as horrible. I see what's happening. Where can you get the full expression? I don't know. Yeah, so it's gonna be a sub visitor, body visitor. So now we're gonna do double recursion. Yeah, visitor for the visitor. Dog, yeah. Yeah, dog, I heard you like visitors. So I got you a visitor for your visitor. All right, instruction collector. Multiple classes. This is gonna be great. All right. Collected instructions. This is actually exactly what we want. All right, we want. Is this a list? Yeah. I guess this could just be none until we. Oh no. Did that just work? Nothing ever works on the first try. All right, cool. Yeah, it did work. All right, so now we got all the sub instructions. All right, now I need the AI to be like, how can I convert all sub instructions into expressions that I can in Python? All right, if this actually works, then maybe we'll take our jobs. Boo. It just gave an example. It coughed out. So if it's an add, then it will do the add. So like I'm gonna have to write handlers for all of these. Is what it's saying. Okay, well there's only like a small set of operations, so yeah, so do on the same wavelength. Crap, what was it, op name? Crap, it's not the right block. Oh, maybe it is. Expression, if. Is there like address or something? The, okay, let's hope it figures out what I'm talking about. These are the wrong instructions. If it's an instruction. What are you talking about, Willis? No. I'm trying to do what you said. Get the expressions and then evaluate them, like manually. No ASM. Okay, call, yeah, that was yeah, okay. And then, forget this, 2x. Oh, it's because it was the wrong function because I'm an idiot. So let's get this. Hex file. Yeah, that's much more simple than this. All right, so it was working, but it was in another function. Instructions in for loop. Okay, there's two of them. There we go. All right, now let's get, so we have the two instructions, and then, how did I do the, man, I'd be screwed without the AI. Like this would have been impossible. So like, yeah, I'm gonna have to write handlers. Okay, so there's a block and then an expression. So how do I access? I think now I need to get the expressions. So it'll be like what we had before, right? I don't know how to print it. Yeah. But yeah, I don't know how to print the AI just lies to me. Print one? Do you think that's actually it? I should just use the header file. Oh my god, it might be. Oh my god, I think that is actually right. So what is it, like hexrays print one, or hexrays IDA underscore hexrays. Hey BlazeBits, what's going on? What an obvious function. Yeah, totally. Is it, do I call it on the instruction? What did the AI say? Yep. And then you provide none. Just check that stream. Oh, cool. Awesome. What's InfoSec streams? What is that? What? There's a website? And I'm on it? Yo, sweet. Wait, I'm just gonna check this out real quick. Oh, cool. I did not know we were on here. Very cool. Print one. If this actually works, I'm just gonna go cry in a hole. Oh yeah, this looks readable. Is it like UTF encoded or something? I don't understand. We're reversing a payload from a C2 framework called Sliver. Oh my god, sorry for the brightness. This thing. Yeah, exactly. All right, let's see if we can figure this out. So, flashbang. Okay, so I think we need to visit the expression. This is getting very complicated. Oh yeah, so sorry, let me keep explaining. So this open source project, you can generate these like C2 payloads, basically pieces of malware. But in their pipeline, they have these this project called Garble that basically obfuscates the Golang code so that it looks like this, like all crazy. And for us to extract valuable information, we need to basically parse out this decompiled code and then evaluate it somehow. So basically I'm just working on parsing out this code, but I'm not really used to this API, so it's taking us a little while. So we want this expression collector, and then we want to, okay, so now we're going to walk each expression within the for loop, and then we can just leverage this to say print expression op name. Sorry, I really wish I could just show the expression though, so I don't think we need this anymore. I think we could just provide the for loop body. Okay, let's see what it was providing the example. Expression collector, what's it taking? CTree visitor. Oh, in the decompiled function. The for loop. I know we do need that for loop, sorry. I don't know how this works. Because it's expecting a body. All right, so we have sub add. This is very hard. Sergey, are you still here? Yeah. Yeah, let's get the vars. That's a good idea. I'm surprised that it even worked though. Because the body, yeah, I guess it looks right to me. Cast, var. Yeah, no worries. It's all good. Okay, so yeah, let's get the vars and see what we can get from them. This is crazy. This is so hard. Get lvars, then I have to look it up in the index. Yeah, like I just need this part, and hopefully it's not a hallucination. Oh god. I think I need to get the functions lvars. I'll just get the function index back from this class. Or the and then we want that other code here. What did I call it? Collected instructions? No. Variables, yeah. Oh, that's a built-in name, which makes a lot of sense. 73. Really? Why not? Why can't I access it? Oh my god. Thank you. I don't know how I can access this outer function. But I have to go all the way back up our recursion loops. Oh god, what did I just do? Sorry, I know I'm not very talkative right now. I'm just trying to figure this out. So the loop iterator and then the okay, so we got the loop iterator, or sorry, the loop index and then the local variables to the loop. This is really hard with recursion. That's okay. All right, I think I'm gonna go for a quick bathroom break and then I'll be right back. So hold on 2 seconds. All right. I think I'm gonna change the music because this thing definitely loops. Is that too loud or is that okay? Okay, so we have, we're also gonna want to get the number of iterations, right? So this, let's see if this even works. Because all right, let's see if that's right. Post, C expression T, pointer or array. Condition. I really wish it would stop hallucinating. INSN details. Step and init. Didn't step not work earlier? All right, it was a. Oh, this is not great. I think it's got to be. Here's all pre-alloc stuff. Okay, so property, but how can I access the actual value? See, it's just all proxied, so it's like very difficult to, I might just work on getting the integer values and then worry about the number of iterations in the for loop later. Yeah, like it's not giving me the actual value. All right, let's try the variables. Print the items, yeah. Print the item. Yeah, I don't think so. Okay, let's try finding those variables beforehand. I assume we're gonna do it by index. Yeah, so I'm accessing it by index. So that's not terrible. Should I? No, we're gonna have to reuse, or we're gonna have to create a different visitor class here. More code, lots of code. And this is a expression visitor. Yeah. Yeah, so that's what I'm, so we are collecting them. So that's what like I propagated to the, so that's these that I propagated to the beginning. Or sorry, we don't actually have to collect all of them. We can just, I see what you're saying. Okay, let's just work on finding them first and then see what those assignments look like. Because I think these are going to be, because I don't know if these are going to be code assignments. Oh yeah, they're assignments. So they're expressions. Cool. So yeah, I should just be able to evaluate whether the assignments are variables that are within our for loop, right? And then I think I should be able to still pick up this comparison using this technique. All right, let's do it. All right, and then we want, this needs to be a expression visitor. So let's look at that. Varnet finder. And then we want the vars. What did I call this? Target VXID. I know this looks crazy complicated, but basically I'm just creating a new visitor using the varnet finder, which is this thing. I have these target VXIDs, which are just variable identifiers. And then I'm creating a visitor expression that's looking for an assignment, getting the left-hand side, the LHS of the expression, so the X value of the X and Y, checking if that is a variable, getting the ID of that variable, and then checking if it is within our target VXIDs. This is like crazy complicated for what we're doing, but cfunc. I guess I can do that in the constructor. Yeah, that was from the, and I just forgot to remove it. I should probably add those. There, we can just eliminate that step altogether. Target var name. Varnet finder. I guess we need to, it should be finding all variable assignments, I'd assume. But it's only finding the, this is the worst. I bet it's like, I'm gonna have to write an array access thing, and then like these aren't actual variable assignments, they're like array initializations. Oh man, this is brutal. Like, are these even arrays? Yeah. Okay, so at least they're arrays. Yeah. Yeah, I'm definitely like, how long have you been doing this for? 5 hours. Definitely a good way to learn how to use the Hexrays API. All right, so it's a, okay. Oh, this is so gross. Check out this monstrosity of a statement. This song totally reminds me of Dota. This song. This would actually be impossible without Copilot though. Like it's not 100%, but all right, let's see. So we have an assignment, a pointer. All right. Y op. I really wish it would tell me what this was. It's an expression assignment. So expression. Thanks, man. Daft Punk works though too. It sucks that you can't access like the top level variable assignment or what variable is being assigned within the top level expression. Maybe I should do it that way. Sorry, instruction, not expression. Oh yeah, this would totally be faster. Or just doing this. This will be faster. Maybe we should just do this. Maybe we should just give up. Yeah, this thing's not good. I think the for loop is okay though. Here, wait, I want to run this and see if it works. Sorry, I'll look at the video in a sec. No, it didn't work. At least out of the box. I could debug it, but I kind of want to focus on our code. Okay, so this didn't work. This giant gross thing. And I will go to Sergey's video now. I wonder if I can be like, maybe this is like super meta, but what if I was like, write IDAPython with the hexphrase API to access the integer values in the array. If this works, I'm just gonna go to bed. Just caught bar is all I have to do. I think Robert East is right though. I feel like I would get better. Yeah. But I just want to see if this will actually work. Wait, and expression V in no. Alright, so that works. I don't know why there's a bunch of negative ones though. Okay, so it's kind of weird because it's saying these are the same memory address. Oh, these are only finding the i's. Maybe I should exclude I from the list. Is it because of the... Dude, like, look at this. Look at this. From a usability standpoint, this API. Oh, you just have to access 2 X's and then you'll be at the right place. It is a troll. I think this looks okay though. Print one. Yeah. What's the v.idx? Because of you. That's why they're disabled. I feel like these are right, but I'm just not printing out the right value. All right, we got the addresses. This is brutal. Look at this. Like, look at this. Look at this code. This is actually crazy. Not really. Smash Mouth is pretty good. Hey, Leet Linux Hacksaw. I'm just gonna turn this down a tiny bit. So I'm writing code to parse this obfuscated code to try and deobfuscate it using IDA. So this is like a reverse engineering tool, and we're writing code to like parse this stuff and then extract it out so we can deobfuscate it. Ooh, Hanson's good too. These are all really good suggestions. What is the code from? What program? I'm writing for like this reverse engineering program, IDA. I'm writing for its API. Does that make sense? Oh, sorry. The target program. So this is from a project called Sliver. Yeah. Thank you, BlazeBits. So I just generated this payload to like mess around with. Yeah, I was with Sergey when he saw Hanson live at Disneyland. It's the most random thing ever. We weren't like in the crowd. We were like off to the side. But yeah, Elite Linux Hacksaw. I generated a payload with this tool, which is like basically generates like a malware payload, and then I'm trying to handle some of the obfuscation it's using. Does Bishop Fox have a Minecraft repo? No, I don't think so. They're like a consulting agency. Yeah. I don't even remember what the crowd was like for that show. Okay, let's get these values out. I have no idea how, but let's see. Yeah, that did happen. Okay, nice. Okay, we were listening to Sandstorm with the guy. I want to do this because I want to go to bed because it's way too late. Not that I'm not having fun, because I am having fun. And I shouldn't complain because Robert Yates is still awake. Go for broke. Yeah, there you go. All right. Expression visitor. All right. How do you think I can access these objects? Like how I can get the integers out of these. I think they were here. Or that's what all this stuff was that wasn't working. So maybe I'll try and get that working. Value. Okay, value. Value has no attribute value. Ooh, what do we got here, BlazeBits? Move your feet. Oh yeah, this song's good. I think we got him. All right, so I'm going to assign this to the same thing. Yeah, those are the right values. All right, so we basically have to write an evaluator for this expression. But given how late it is, I will most likely just do this myself. And then I'll probably do that on my own because I feel like it's an exercise worth completing. All right, so the next thing we have to do, instead of just me doing it, I want to see if I can collect those instructions. So we're already collecting the variables. So the for loop collector, it would be in the for loop collector. Now we're just going into madness. Okay, now Robert Yates had a bunch of good suggestions. Okay, so this actually could be a pretty cool method. Is you could evaluate the expression to see if it contains these series of operations, and then you can identify that it is indeed like this array subtraction method that they're using, and then you could potentially use that for others within like the for loop. All right, so the I'm just trying to figure out what, like I wish it wasn't so complex to just establish that this was a sub. Yeah, let me play the is there a way to execute code and recover the final from memory somehow instead? Yeah, there is. Basically, I just want to try and do this statically, so like only by reading the code essentially, which is like a lot harder than just dumping it from memory, because dumping it from memory takes a lot of like computing power, whereas like this method takes less. I don't know how to check. Here, let's see what the other expression looked like. Is this not an assignment? But usually that way that you described is what a lot of people do. So, okay. Oh, wow, it's not even finding the assignment. I just want to know what this expression is. No, I got all the variables. Like that's all done. So that's what all these value, like I got all the array assignment values that we worked backward from the variable assignments in the for loop. So now I'm just trying to like fingerprint this operation. So we don't have to like re-implement it operation by operation, but the code that you're changing. You're right. Oh, that's in the body. Yeah, sorry. So I know this is super confusing, but this is the expression collector for the for loop body. But I thought you were right for a second because this code is really confusing. So yeah, so the expression collector is used down here. So for the instructions found in the body visitor of the for loop. Yeah, it's horrible. I just don't know. Oh, maybe if I do this. Do you think this is actually it? This is crazy. This is it. This is how I can fingerprint this method. So, okay, so it's really tiny. I wish I could zoom in, but like it shows an item, and then that item contains this code. And then it's made up of these operations. Here, I'm gonna play what Sergey just did. Here, let's try this if statement. Look at this. Okay, hold on. I'm gonna have to do some string replace on this giant expression. This is the crazy. Sergey, just see it. It didn't work. Oh yeah, it did. You just have to believe in the insanity of the API to know that things will work. Yeah, I found it. That worked. Oh, I see what you're saying. No, I know. Sergey, my idea was to basically write fingerprints for all the different methods and then write ways to reverse them instead of like evaluating all the expressions. Okay, so let's tie up this stream by doing this operation or like re-implementing this on these, and then I'm gonna go to bed. Yeah, I don't think they will either, to be honest. I think we should have gone with emulation. I don't know. It's still a good way to learn the API and the tools, so whatever. So and then self, and then I can't believe this if statement works. Why can't I do this block comment? What did you say earlier? Okay. Okay, now we have to troubleshoot that code that I wrote earlier for us. All right, I'm gonna do that later. So it's just like literally a subtraction, a byte subtraction, right? Oh no, these aren't equal. I didn't track which variables are being assigned which value. Okay, I'll fix that later, because otherwise we're gonna be here all night. Oh, it's doing a byte-wise subtraction. Oh, I need to concentrate because I need to propagate this method up the chain again. What's the fastest way to subtract each of these bytes? If they're keywords. The overflow, you will need to do it byte by byte, yeah. Is it the syntax? I can't remember. This is confusing. I'm just gonna do the is it not iterate? Enumerate. I always forget that. Y'all still there? Almost there. There we go. UUID, incorrect UUID format in string. All right, to recap, we wrote 3 separate recursive functions to, 1, capture these integer assignments, to first capture the variables within the for loop, and then we wrote another one to capture the integer assignments, and then we wrote another one to identify this obfuscation method in a crazy way. So using this, but it was very fun, and thank you for joining and sticking it out. I was about to give up. I was very close to giving up. All right, well, I'm going to put this horrible code on GitHub tomorrow. Yeah, definitely the friends we made along the way. So now to identify the other methods, and then right click on these and then do the same way. I will bid thee good night. Thanks for sticking around. I'll talk to y'all later. But yeah, take care, y'all. See you next week, Sergey.